All right, here we have the Effect House version of the emitter effect, which is a misnomer for Effect House because Effect House does not have emitters, particle emitters, the way that Meta does. So I've cheated a bit and created a sprite sheet that replicates the same thing, which was something I had to do in a real world situation where the client needed something on both Meta, like so Facebook, Instagram, and TikTok. So what do you do when you have a situation where you want to create something that's available for all of these platforms together, but the platforms themselves don't all have the same features? Well, this is one example of that. So first, let's take a look at the effect itself. We have a title treatment up here, and we'll play. What? Hairballs? Whoa! And here we're in a totally new place with a cat bouncing up and down on a couch, as they do. So let's go up here and just check out our hierarchy. We've got our TT camera. TT's for title treatment, kind of a standard marketing ad buzzword. And that's just managing a few of the 2D elements within the... All right, let's get into the node graph here. Come in. This is common in a lot of the templates when you see tutorials and such with Effect House, is that as a kind of an initialization step, you'll get a lot of elements strung together like this, where you have elements with this next triangle stringing down into the set of another one or to the enter of another one, and just stringing them all together like this. TikTok really likes you to, even though it provides you with abilities to do things concurrently, I would say that the architecture of a lot of their effects from a node perspective really wants you to flow data from one to the next in a fairly linear operation. So that's what we've done here. And we have our fill up a plane, the hairball plane. Initially it is on, and that's okay because it's below where you can see it. So it doesn't matter if it's visible or not. The position is the important thing, and it's set way off screen. So that all gets, as soon as this effect starts the screen tap, we're getting this reset functionality. So we need to make sure all of our values are off screen. The hairball plane is off screen. This isn't visible. This isn't visible. This isn't visible. And that's all of what this is. It's setting these initial values, setting initial visibility. The background, the cat, the replay all need to be visibility off. We also have this facial movement detection node, which is built into Effect House, nothing special that you have to make on your own. When you come out of here, though, you want to make sure that it's only happening once that your mouth opening triggers something. Otherwise, you would keep kind of re-triggering the whole effect after having already had the transitional experience here, and that would look funky real quick. But fortunately, Effect House gives us a do once patch, do once node. So if we get this, or we get that screen tap, either or, now we get into the business of running the effect. So let's look at these first, this little grouping. We're going to turn on the visibility of the puke quote-unquote emitter. Let's show that again real quick. And that is that. It's also going to play, as it receives this, it's going to immediately play the animation sequence for it. Now, I've kept this in for the purposes of demonstrating how Effect House will deprecate things. It will still function, but you'll see, because this is a beta platform still and things are not finalized, these nodes may change. Fortunately, they don't always just break your effect on you. It used to be that they would, but there is an option now. If I go into node, animation, animation texture player, which will give us the same information. It's just a change in how they're designing out the platform still. But I'm gonna leave this in because if you are jumping in and doing some quick start stuff and getting your stuff out there, these platforms are going to occasionally deprecate stuff on you. So you need to know how to pivot around that. And you may also notice that if you go to the documentation for these platforms, they do not necessarily say that they have deprecated stuff on you, and their release notes will not necessarily say that they have deprecated stuff on you. So it's important to be able to roll with the punches right now and figure out what you need to do. In this case, fortunately, there's a one-to-one option here in what we're doing with the animated texture player. But for now, we will just keep the sequence controller. It's working. And we see it's set to stop on last, but a few things happen as soon as this plays. We begin a delay in the form of a wait for seconds node for 1.5 seconds, 1.5 seconds. And when that delay is finished, it's going to turn the visibility off of that puke emitter. So actually, even if this was happening more than once and you're opening your mouth, this is a safety here. This is going to stay invisible. So after our delay of 1.5 seconds, we're going to come down to set visibility and turn that emitter off, so that nothing's going to show there. For a couple of reasons too, because right now we're also using that do once node. So you're never going to pass this. When it plays once, it also is going to trigger our audio sequence controller. And remember, that speaker wasn't showing us the puke MP3, but that's okay because we can grab it in this way. We can just pull in that MP3 and it exists as a node there. Tie it into your sequence controller, it plays, and it's tied to that speaker. That takes us into this next section, which is the puke. There's an additional delay here because we want to keep it up. It's going to take some time to transit the hairball up, the hairball pile up. You see here, the fill up object. It's going to start after almost a half a second to transit by time, which is a vector 2 patch, meaning it's going to take X and Y values in this case. And it's going to keep feeding those values to this object. So you see here you have a few options. Begin will only trigger once, which isn't good for us because we need an animation. It's going to go over the course of time, each tick or frame of that animation. That's what that stay gives you, is this ongoing output of data. And as that is ongoing, it's giving these values. So over time, it's filling up on that Y plane. And when it ends, we have a bit of a delay, about a half-second delay, not about a half-second delay, before we play the audio for our explosion. And then we see we have our explosion object here with our deprecated sequence controller. As this plays, it plays with a small delay all of the things that need to happen during that explosion sequence. We toggle off the visibility of that hairball fill up. The background turns on. The cat and the replay have their visibility set on. And we have the explosion, the delay. You'll see there I had some nodes that did not need to be there. Quickly took care of that. In any case, so we've set our visibility on for replay and cat. After a delay, we start to transit by time our replay. So we get that rotation. What we're looking for is that number to affect the rotation of replay. So we begin, and as we tick through, we change the value from 0 to 360 to get a full rotation. Take a look at that real quick. And that delay is so that you actually get to see that animation play. Otherwise, that explosion and all that stuff could risk overpowering and hiding that animation. Now we have the cat, which I just put here because in the flow of things, the cat doesn't appear until the end, right around this time. But as you can see, it's not actually connected to anything. It's not dependent on any of this data flow. It's always kind of running. So let's break into this subgraph here. And I have done something obtuse and a little funny here because there is a patch you can use, and you already saw it, the transit by time. And if you are to add the transit by time node, you'll see an option there is ping pong. Ping pong, like it implies, will reflect values back and forth with each other. So to get that jumping cat, you could just tie the object to the transit by time, give it a big loop number, make sure this is checked. And that'll give it to you. That'll give you this. But there is often more than one way to do things in these effects, and that's what I wanted to show here. Feel free to destroy this and use the much simpler option if you want. But I'll quickly run through how else you could achieve this effect. So this is, instead of relying on a patch that kind of locks you into the functionality of that node and its sort of black box characteristics, there are other ways to get these values to ping pong themselves. So what a ping pong kind of looks like is we have our cat, and on update, which is each tick of the effect, like as the effect itself is running, each tick of that, we're going to get new values on the position for this cat. And what this is a clamp. If either of these things end up being true, then we are going to reflect back, which is like reverse the values of this float speed, which is not a built-in node. It is a variable. And even though we're in a subgraph, it's not a subgraph variable. It is the variables are accessible from subgraphs, even if they're made outside in the parent. And in this case, it's an XY value of vector 2 that has an initial 2 setting on it, like a default setting. But that's always getting referenced and kicked back to here. So for example, we have our cat position here, which is a vector 2, an X and a Y. Where is it on the X and Y axis? And that's going to keep changing because at a certain point, it's going to add up, and if it passes a certain bit of logic, this will be true. You'll get it so where this triggers, you've got that blue here, it's triggered. Now it's just waiting for this condition to trigger, and then that will send this true. If it's not true, you get a false signal. So we'll look at this area real quick. Watch how they go back and forth triggering because these values keep getting reached and then sent back with this reflect vector. I know it's like I said, it's obtuse. It is a complicated way of thinking about just having something go up and down. But when you really break apart how these nodes operate, it can be math like this. Like I said from the beginning of the course, you don't have to know how to code. But if you're curious or you want to know what's really going on and really give yourself, and this is my real point, the ability to really customize your effect and start to add your own touches on things, getting your head around how this stuff is working will give you that flexibility. Because when you use transit by time or these built-in nodes, you can still be very creative, but you're going to be locked into what those nodes do and have to kind of branch out and possibly get confusing as you try to customize your stuff. So I just wanted to give you an option to look at and parse through, to reason about how else you might achieve the same things. You can still do it in nodes. Nodes don't necessarily lock you in and force you to only be able to do things one way. And that's it. If you look at the runtimes for this is a much shorter walkthrough and tutorial than the meta version. The Effect House version is a little simpler, but also is not using actual particle physics. I had to make a sprite sheet or texture sequence of these semi-translucent hairballs pouring out, which I did in After Effects.